Alright, so I'm going to do a demonstration on this, and I'll tell you right now, if you're just getting in here, it's going to be a fairly long video. I'm going to try to keep it without missing stuff. So this is truly not about the quote-unquote the power or the input reflection I have between each or any amplifier I have here on the bench. They all don't always match up. So you have to keep that in mind. This is just a preliminary test. I'm showing on an RF load on a power supply where in all functions of this power supply, and then at the end I can take and throw the carbon pile on there and we can take and load it down. But over the years, a lot of people had taken and they attempted to take and build power supplies, and they do maybe a review or not. You get phone calls, or I have this one, and what do you think of this part, and what do you think of this one and that one? I really don't have opinion. I use the devices I use, and they work for me. So if you have a power supply and a source to get the power supplies, and they're functioning and they're working well with very little floor noise or noise to them, and getting into receives and extras, if that's working for you, just keep on doing what you're doing. It's because today, in today's times, everybody can take and have the access to the same parts that everybody else has. And it's really always been available. But it's how you choose to use the parts and understand what you're using and how you're going to manipulate them to do things for you or against you, however you want to look at it. So we're gonna dig into this, and this unit here is I kind of named it a 400 plus special, and the special portion of it is that there is a potentiometer on there, and there's an extra 100 amp power supply in here. So that said, let me carry this over here real quick, and let's take a look at this unit. So good evening everybody. I see Adam's in here. I don't have my glasses. I don't know where the heck they're at. I probably should get them. But as far as the equipment goes, and I want to make a comment because someone had posted, I think it was on YouTube, and they're like, dude, don't you know anything about editing? I watched this and nothing happened for 2 or 3 minutes. This is a live broadcast video. So if you don't have time to sit through it all and you come back and watch it, because I post them up later, so people come and go. But as far as editing, it's not happening. That's why I do it live. I don't edit anything that I do when I work on this type of equipment. I don't edit anything. I do it live, and that's a purpose behind the live build, because anything can go right or anything can go wrong for you. So if you think that I need to edit videos, you're talking to the wrong guy. Because I'm not the guy that takes and records something off screen. If it didn't work out for me, I edit it out of my video. No, I'm human, and things do break down, and sometimes they happen during videos. So I expect that's not going to happen here. I hope and pray and knock on wood. But with that said, let's take a look at this unit and see what we have going on. All right, so this is like, I've always set my power supplies up for this specific reason. First thing is, when I turn one of them on, the inrush is only basically for one, but the inrush has to take and fill all of the capacitors and all of the power supplies that are in here off of the B+. So when I hit this and it brings 100 or 200, 240 volts in on the switch, it says, hey, one module will light up. But that one module has to fill all of the little electrolytic capacitors that are on that B+ bus on there. So technically, let's say you have 2 capacitors in there at, let's say, 30,000. So you have 60,000 worth of capacitance you have to fill on that one that you're turning on. But you have another 60 here, another 60 here, another 60 here, and another 60 here, even though it's on its own circuit. Well, actually, no, this one wouldn't count because it is on its own circuit. So you're asking one power supply to turn that on. Now, you could take and use a contactor, turn them all on at the same time, but this system works for me because if one of the modules goes out, or if I don't need them all, I can simply turn off a switch. Okay, I only need 100 amps, I'm turning on one switch. I want 200 amps, I'll hit another one. I want 300, I'm gonna hit another. Hit 400, I'm maxed out. That's it. But if during any time any of these 4 fail, all you have to do is shut the switch off, don't worry about it. You still have 300 amps until you get it serviced. So that's this part of it, and it's set up at 15.5, or no, 15.8. Let's take a look at that, how it's set up. So this little all-in-one digital amp meter and watt meter and energy meter is really cool. You have a couple different things, but you can shut off the backlight, or we can choose to leave it on. So this is where my voltage is actually resting at right now, with no load on it whatsoever, and she pretty much likes to hang out at that number, and that's cool. The decimal point on this amp meter is actually in the wrong spot because it wasn't designed for this. So when you look at this meter, just disregard this decimal point. Don't act like it's even there. So this would be whatever, I would hit 300 amps, it would come across here. You'll see it as we bring it up, but you'll forget all about that decimal point once I start loading this machine up. So that's the amp meter. There's some other perimeters you can set within this for a low voltage alarm, high voltage alarm. It don't have a audible alarm, it's just a flashing. The light on this just turns on and off. It just blinks rapidly that you're in overload or overprotection mode. It just kind of does that. So I simulated that for you. Now, this side here is a variable voltage. And this switch, so you can see this one's off, this switch is sharing this meter here. You see it just went off. But when I turn this switch on, it'll come back up. So what that just happened there is I transferred my voltage reading from this meter by simply using a switch. Up is for the low side, that's the smaller power supply. It's a 100 amp power supply on here. I have controllable voltage. So let's take a look at that controllable voltage. I can go as down as low as 11.9998. All right, so that's bottomed out. So let's say you crank it up. Now I put a ceiling on this one where I hadn't did that in the past, and this is a multi-turn pot. So it's really nice because you can use it for fine tuning if you're trying to do something like that. But here is the maximum resting voltage at 16.05 volts. So give or take, these meters are they're just an item to measure what's kind of going on. This is not lab science accurate, but everything pretty much exists pretty well as far as, you know, measuring out pretty well. I'm trying to think where I was. I think I was down here around 12 something. So, all right, we have nothing to drink over here, and I got a scratchy throat. Give me one moment, and I'll be right back. I can grab a water or something. All right. Okay, now let's keep on going on this. So as I just explained, this portion of the system is independent from this 400 that's over here. So the 400 is still running, and that I just flipped the switch down is all I did, and it transferred over. Now I'm reading on this side. So with that said, all of this is tied together for the measurement for the amperage. So you're running your radio off of this unit, you can run your driver off of this unit, and your big box all off this unit, all plugged into one cord, 240 volts. Now the amperage is shared with this 100 amp and this 400 amp. So when you measure the amperage, unless you take and just measure that box, you would flip it over to that switch there, and you would measure that box, but this one would have to be shut off, vice versa. Now, when you run them together as a whole, then you get the whole number of what everything is drawing on your amperage, and you would be able to read what's happening on either or side, meaning if you're on the small side, the power supply side of the driver, you would flip over here, and then you would be able to monitor what's going on with the voltage. So let's take a look. I didn't label it all up in the back, but we're going to get into the next portion of this. Obviously, there's no room back here. My camera's too big. Oh, come on, shrink, baby. There we go. All right, so in the back, this is the 3/8 stud is for the drivers. They both share the ground, so the ground is right here, and the ground is shared for the driver, power supply, and the big power supply. So here's a 400 stud here. It's a 1/2 inch bolt. The circuit breakers along the bottom, 5 of them, one for each module is in there. So you have shared ground. Now in the back here, there's a radio jack, and I actually have that plugged in up here to Texas. So let me show you something. Y'all don't need to freak out about this. It's still all good. Now this is resting. This unit's on. I'm going to cut it off. All right. So here's the idle current with just a radio plugged into it. Okay. So as soon as you plug your radio into that jack, you're going to see this 15.6 or somewhere right in there. You're still good. Now, if I didn't even have that radio plugged in there, that number right there would actually be higher. There's absolutely no load on it. Now, I did leave an extra part in there, so if somebody wanted lower voltage when they're transmitting, then all I have to do is just move one wire. It's very simple. All right, now as I get ready to turn this back on, just energizing my radio, look at the voltage. Okay, perfect. It brought me down 15 volts, 14.99. Now that's great. Let's take a look at a load. Now here's a radio I'm going to be talking on. Audio 1 2 1 2 1 2 1 2 1 2 1 2 1 2. So that radio is running right at 14.8. Right where you want to be. It's a good spot. 14.2 to 14.8, somewhere in there. The radios will respond and do very well, depending on your technician. So I think I covered all the bases on the low ends of this thing. So let's just take and light up the driver. I'm going to cut this off. No need to look. Well, I'll turn it. All right, it's not going to change when I run the driver. We'll look at it. Then we're going to look at this down here. And we're going to put this on this voltage. Okay. All right, so let's look at, now I'm going to hit it with the driver. Driver, radio, I got the radio going into the driver. So obviously we don't have to keep monitoring that because it's going right to the same spot, 14.8. Now, driver I have wide open. It's just a little 3-pill. And I'm running, any of these 4 switches will run the radio. Even though the amplifier is off, I'm not using it. I have to use the switch because I couldn't put that radio jack on a variable voltage because you could try something. So I did it on the fixed, but I hooked it up on the slave side of this, or the bank of 400. Any of those switches will power up your radio, and then this is just for the driver. Sounds a little odd, but that's the way how it worked out. Otherwise, I'd have to have total separate power supply for the radio, and that kind of defeats the whole purpose of free energy with this 2, 3, 4 amps that the radio would require. All right, let's take a real quick peek at the bench. And we get a few things peeking and tweaking and tweaking and peeking. All right, so real quick, we're going to look at some amperages. Just take a look at this one. I have it online. Let's see if it works. Oh, do you work? Yeah, you're working. Audio, 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 audio. So it's showing me right around 26 amps. So let's take a look at this one here. Now here's the amperage over here. Let's see if we see about 26 amps or so. Audio, 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 audio. Showing me more like 44, 43 amps. I don't know why it's showing me 40. 1, 2, 3, 4, 5. Let me double check something. Okay, let me look at this one. Audio, audio, audio. Still showing me 26 over here. All right, well, either way. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So there's your amperage there. Yeah, power is the power. Let's see, here's a 1,000-watt slug. Audio, power, audio, just a 3-pill running. And this is what I'm going to drive into the 16. Audio, 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 audio. About 220 bird RMS into the 16. And how am I doing that? Now, I'm going to control something. We see that wide open. We already know the radio's fixed. So my voltage, I'm doing 220 at 12.28 volts. Let me crank my voltage up, and this is where you have kind of double control. If you're a guy, I really don't like messing with my potentiometers, rolling them back, but you can use them for that. But if I can control an amplifier by manipulating my voltage, I'm always going to do that first. And then if I can't get it to where I want it, then I start messing around with the, well, let's say that was the lowest. We'll just go to the highest right here, that's 16 volts. All right. See if I got some audio. 1, 2, 3, 4, 5. Audio 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I'm at 15.9 volts. He ain't moving. Here's 1,000 watt slug now. Audio, audio, 1, 2, 1, 2, 1, 2, 1, 2, audio. 380 bird out of a 3-pill. Nothing wrong with that. Here, let's see what the digital says. RMS. Audio 1, 2, 1, 2, 1, 2. They show me more close to 450. Let me put it on 2500 slug. Audio 1, 2, 1, 2, 1, 2. Audio, audio. 325 or so. Okay. Let's look at the peak. Pika, 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 tweaka, pika, tweaka. 525 there. Let's look at the 5 kilowatt. Peaker, tweaker, tweaker, tweaker. Showing me 7. Let's look at the 5 kilowatt. Peaker, tweaker. I'm just on a driver. Audio 1, 2, 3, 4. It's about 650, 700. So that little driver is getting up and scatting. No, I don't need that much drive. I'm going to roll this booger right back to where I had it because I really liked it there. Eventually, we'll put some drive into this box. I don't know if I want to go that much, but I may take and just let her rip, potato chip. All right, so now we did the test on the driver. Let's take and turn on all 4 or all on the power supply. And now it's going to run my 16. Just back on over here. Here's a little bump. Got amperage. All right, now I'm still reading my driver voltage. All right. Let's see if I got a carrier. Now y'all just heard that. You heard those fans slide up, right? I'll explain that in a minute. I just want to stay on track here where I'm at. Now, even though the switch and I'm reading the voltage for my driver, let's see if this amperage carries over. Audio, 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 audio. That's 331.9 amps. I'll flip it down now. We'll go back over to the bigger side. Audio, 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 324.28 amps. Okay. So, let's look at what just the 16 is drawing. Audio, 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 it's not working. There, it's working now, baby. Alright. Crazy chicken popped up. Look at that. There you go. Amperage 16. Audio, 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 audio. So 300 to 314 or so. And then the amperage on this little deuce, or 3-pill. Audio, 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 audio. About 33, 34 amps. Alright. So you add those up. You should end up with somewhere in here. Audio, 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 audio. 3, 3, 3, 3, 4. Now, let's look at the voltage. I'm sorry, I'm all over the place with this camera. Let's look at the voltage. 15.6 or 86 volts. Now, if that 8 moves us down to 7, so it reads 7.6, that'd be 1/10 of a volt, and so on. Audio, 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 audio. So a little over, no, a little under 1/10 of a volt drop at that output of the 16 with, I don't know, what are we using, workable drive? 1,000 watt scale, audio, audio, workable drive, audio, audio. So I'm doing 200 watts into this unit. Input reflect, it's probably a little bit high because I didn't match everything out. Audio, 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 about 5. It's not the correct driver for this box. Let's look at the 2500 analog. Audio, 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 audio. So that's a perfect times 10 input drive. A little better actually. Audio, 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 200 there. Audio, 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 audio. So right around 200. And so the 2,000 watts and 200 in. Let's look at the 5 kilowatt slug. Center scale, each line's 100. Audio, 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 audio. Wow, that matched up really nice. So let's go ahead and let's look at the peaker tweaker. Tweaker, peaker, peaker. Peaker tweaker, why did my box blow up? Audio, 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 audio. So we're hanging out right about 3,000, 3,100 there. And let's look at, that's correct. Okay, the 5 kilowatt peaker tweaker digital, audio, peaker tweaker digital, 1, 2, 3, 3250 at 200 watts in. And I'm at elevated voltage. I sure am. I'm guilty. I'm guilty. I'm not doing this at 14.8. It don't matter. As long as everything's happy. Everything's happy, I'll run all day for you. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Break up, break up, break up. So, as you talk into these, power supply tests are really boring. At least I added amplifiers to this one. Commercial break. Last one of those. I gotta get some more. But I have a 4-pill up here, and it does, I think it's 4 2879Cs, and I drove 16 2879Cs, and it worked in, I think I was like right around 180 watts of drive, just my radio running it at 14.8, and this unit was running, geez, I jacked as high as I could, and I get maybe about 200, but that's why I ended up taking and going to the little 3-pill, because I can increase my stuff now. And with that, I was just kind of stuck. So I never removed it last night. It's still sitting up there. Okay, now, the driver's wide open. I have nothing I can turn up here. Nothing I can turn up here. Here comes the magical charms right here, the lucky charms. So, either it's going to make you or it's going to break you. And if you don't mind your drive, meaning your drive that your driver's putting out into your box, and you crank this wide open, you could overdrive your box depending on what size box you have there. I'm really controlling this one. So by really controlling this, I just ran that unit where it did about 200 watts. I want to make more power. So I'm going to take and I'm going to crank this thing up. And we're going to just go on up. All the way up. Hell, to do a test, you may as well do it. I did the minimum, I'll do the maximum, and you kind of fill the middle in between. Hey Steve, how are you tonight? Okay, so cut this off real quick, and let's just take a look at that driver, what we got going on with it. We saw it earlier, but we're going to look at it again because I'm fitting to drive it into my unit. Alright, here's a 1,000 watt slug. This is a 3-pill by itself, about 16 volts, audio, 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 audio. So about 360 watts or so. Let's see what we're doing here with the voltage. Audio, 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 audio. Wow, she is solid and drawing about 52 amps. So, let's set a dead key and let her rip, Dave Chip. Let's see. Alright, we're going to talk about that real quick. Did you hear those fans? Now listen to the fans. I'll explain why it does this. Hear that? Sped way up. They're speeding up. Why are they speeding up, Danny? Because you don't have no dead key. That's all fan noise. Now watch. Mic gain off. It's doing it. It's oscillating, really. So you bring the carrier up. There you go. About 1,200. My gain was still off, and I'll turn it on. Oh, okay. Audio. Bye-bye. That was a 2,500 watt slug. That's what drive does to your equipment. Now let's look at that on another scale. Let's look at that at a 5,000 watt scale. Each line's 100. Audio, 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 audio. 28. Let's see what we're here. Reflection, RMS. Let's look at this. Audio, audio, audio. 25, 2600, 27. Audio, worldwide, worldwide, worldwide. I don't know why it's freaking out like that, but it is. Alright. Here you go. Peaker tweaker. Peaker tweaker, audio, audio. 4,100. Let's look at the peaker tweaker up here. Audio, 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 audio. I would say they match. But again, this wasn't about the power level of my amplifiers. We already know they work. This is all about this power supply. So, this is my driver voltage. Now here's my main voltage on the 16. And then this is a full all amp draw. Audio, 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 audio. 380 some odd amps at audio, 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 audio. 15.66 volts. Looks like a couple tenths of a volt to me. But see, that's a lot of drive going into this at that voltage. I'm at the top end of my drive. So I'm not going to take and roll this back. I'll go back over here and say, I don't need all that drive, man. I'm backing this voltage off. In fact, I want to go, let's go about right here. Let's go at 14 volts. See how it runs at 14 volts. That might be a good number. Audio, 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 audio. There's 300 watts. Everything's ready to go. A little carrier. Perfect. Alright, here we go. Drive. Audio, audio, audio. Why did I lose 20 watts? A little over. Feeding the circuit. Because I did a bypass and I loaded it up to 300. Now when I turned on my amp, it just ate some of it. Here's a little input. Audio input, input, input. A lot better. And here's a 2500. Audio, audio, right close to it. 300 watts of drive. RMS 5 kilowatts. Audio, audio, audio. Right around 2500. Let's do 5 kilowatt digital. Audio, audio, audio. 2250, 2400. And peaker, tweaker, breaker, breaker, breaker. 3550 watts peak. Again, it ain't about the power. It's about the control that you can make your driver do. And it controls the whole system. So, as things evolve and people build different things, this is just the thing that I'm building. This unit, I'm really proud of it. It wasn't a terrible build. I didn't have a lot of problems. Everything flowed and went together well. And any problems I had was actually self-inflicted. I had a bad solder joint on circuit board and it gave me some flaky numbers. But after I corrected that, she's solid as a rock. That was my only glitch on this whole system. So we could take, and now we know that I can run my driver. If you choose to add a 5-pill or a 3-pill or a 2-pill, whatever driver you want to use, a 1, 2, 3, 4, 5, you put it on here as long as you don't exceed 100 amps, meaning for this section of the power supply on your driver. Now, this system's only going to draw so much. So now I'm going to take and disconnect a few things, hook up the pile load tester, and we will take and look at some maximum current draws. And when I take and do a pile load tester, it's more like taking and putting an elephant on a mouse's shoulders and telling him to stand up. It's ridiculous because we're putting the most crucial loads and most demanding loads that the power supply will probably ever see. Unless you're one of these guys that has an amplifier that throws a huge carrier, and then when you talk, it backs up on the watt meter and on the RMS watt meter, not the peak. And your amperage literally will have a huge number. And then as you talk, it will decrease, just like your power does, or your wattage of your amplifier would. So when you back up things, it just don't back up very nicely. It should a 600 amp. Actually, I didn't even mention that. This unit does not have a home. I decided to build this unit. It's the first one that I've done like this, of this size. I've done other ones. I did the 800 plus. It had 9 modules in it, and the 9th module was for the radio drive system. So this is something that I'm offering. It is on my price sheets and everything, and this one does not have a home. I built it, and if bigger is better, you got that right, Rudy. So if somebody's needing this power supply, I can definitely hook you up, PM me, we'll talk about the price of stuff. But with that said, my prices have been listed on Facebook. They're on my page, and you can go look at the newest price sheets with all the tariffs and all the things that they got going on. My stuff went up just a little bit, not lots. Power supplies, I didn't change anything on them. So I added units like this in between of, let's say this cabinet was designed to go up to a 500 amp unit. Now, I ultimately had built in this cabinet just 400 amp units. But then I got thinking, hey, I can put the fifth one in here, then I could literally take and make a plus out of it. So I can do, this is, instead of being a 500 amp, it's a 400 plus. Still has 5 modules in it, but I had to do all this little bit of extra circuitry for the radio jack and this and this and that, and etc. But all of that stuff's listed up. So let me set this to the side for a minute and go to a commercial. While I'm doing this, I'll just turn up a little bit of music and get busy with it.
Let's get it on.
All right.
Let's build some amplifiers. Do y'all even know what they do? Do you know how many amps they draw? Do you know how much voltage they need? How much drive do you put in these things? And what's my steady weight? Oh, my reflect is high. I'm gonna burn this junk.
Burn it, John.
I got a bad jumper in my input. Reflected sky.
Mike Smith did this song.
Gotta have a 12. That's what Johnny Boy told me down the street. Let's see if I can key on you now. That this thing is 100%. I got 10,000 W and no
Oh, no.
DX.
I wrote this song. It's supposed to say watts. I didn't proofread it, and it said 10,000 W, and I said watts. How it goes sometimes. All right. Got an amp lamp around here. Cool. Get this one off. Okay, here we go. Now, this test here is it's called the carbon pile load tester, and this thing is a beast. It really is. This thing is pretty much a beast. So this brings out all the good, the bad, and the uglies about a power supply. That's what this machine does. It works really, really well, or not so much. All right. I was reading a little bit about, someone's asking about prices and stuff. Yeah, and Steve, I'll go back and read the comments later and try to respond to that. So, here we go. We're going to light this booger up. Turn it all on. And we're going to look at, I only have to turn that one on. So we're going to look at the main 400 amp service. And we'll try to refer back to this back and forth best I can. Maybe glare might be a problem. Bring it a little bigger. There. No longer a problem. Alright, let me see if everything's functioning here. And go from there. We got about 200 amps coming up. There you go, 203, 206, 215, 217. Two different points of measurement is honestly is another side of that. You have a machine, you have an amp meter out here, and it's going through this, has to go through this cable where this amp meter is directly coupled to the unit. So honestly, I would expect this one to be more true than this, but as long as they're in the same neighborhood, I'm happy with that. Hey Michael, how are you? All right, so these are rated at 100 amps at 12 volts, these power supplies. Well, we're not at 12 volts, so are they still 100 amps? No, but they still make what we're asking them to do. Because again, this is a machine that will take and make you cry. It makes the power supplies cry when you take and you really lay down that load on there. So let's take and put a little bit of a load on there and pay attention to the voltage on this side and your amperage. Remember, disregard the decimal point. All right, so here comes up about somewhere right around 100 or so coming up. I'm looking at the analog meter, 200 or so right there. All right, the voltage is still really stable. There's 360, 380. I'm holding it down. There's 410. So I'm at 1544. I'm getting close to that half a volt mark. But again, our equipment's not doing that. We're not just loading this stuff. We're swinging it, we're modulating it. So here's a carrier, and this is how our equipment will act with this. I'm going to simulate what our equipment would do with this load tester. All right, there's a carrier. I got a carrier. I got 5, 6, 8 amps, 10, 18. All right, and I got a carrier. Now I'm going to take and say 1, 1, 1, 1. I went too far. I went 400 and something. She's warming up. She's getting more sensitive. All right. So let me try to get that back up here again. Get a little carrier up there. And there's 140 amps. I'll just give it a little spike. As I'm modulating this, that's what your amperage and your voltage is doing. It's dancing all over the place, and that's what you're going to see if you get to the upper ends of the load or the supply. So if you get close to that 400 amps, obviously you're going to have a voltage dip, a little one. But you don't want to dip more than a half a volt, because after that, it totally exhausted the power supply, the service of it. So here we go. Let's see. Let's just do a solid load on it. Well, 100, 200 coming, 3, 4, there's 400, there's 420. Yeah, that's 3/4 of a volt, 420 amps. So it's safe to say 400 amp power supply. If you want to call it a 380, say, oh, he's cheating us out of 20 amps. Not really, because your equipment is only going to draw so much. And first thing is, I'm not that guy who's going to say, oh, you only need a 200 amp power supply. No, you need a 400 amp power supply, because you're a CBer and you're always going to want the next best thing. Your buddy says, hey, I got an 8-pill, I got an 8-pill. Well, I'm going to get a 16. He had a big enough power supply, and you didn't. So now you not only have to get a bigger amplifier, you got to get a bigger power supply. So spend your money one time and spend it smart. Get a big enough supply, more than what you need, and then when you go to upgrade your amplifier, you don't have to upgrade your power source. It's just kind of sensible to me. That's about it. I don't have too much more. Now I could take and hook up this whole little 100 amp deal, and we can take a peek at that. Oh, I know what I can do. Let me show you this. Here's one module. Here's one module run. So I should be somewhere right around 100 amps on this one. Here, crawl up here. Turn, baby, turn. 91 amps. So, honestly, at that voltage there, they're realistically about 80 amp modules, and that's kind of how I called it, 80 amps. Now I can get bigger ones, cost a little bit more money, but it's not necessary, I don't think. See, these are 1200s. If I were to get to 1500s, hey Bill, how are you? If I get to 1500s, yeah, I'd probably have a little bit more headroom, but I would still rate the dang thing the same. So on these, I rate them at face value at 100 amps. I can make the 400 amps out of it, no problem. Power supply obviously didn't even sweat one beat with the driver and the 16 on there. It wasn't breaking a sweat. So I'm really, really satisfied with how this turned out, my decisions on how I built it. I probably won't change it. Now, as far as the decal and the stickering on this one, I just made it very simple for somebody to come along and say, hey, I like that black and silver, done. I just kind of made it neutral on this one. Now, if someone were to buy one, yes, we could do something special on the stickers. Not trying to take and go all extravagant, but if I were to do anything, I could add a stripe in here or two, and then you'd have the lettering going across. So that's your own personal preference. That's something we would discuss if you're looking to get a unit. But in the meantime, between time, Molly is not over here. She's hanging out with the babies. I left a project. I was hoping to charge her out on the building, and I said I'll be back here in a little bit, probably somewhere around 8 o'clock, and I'll finish up this little bit of project, clean up my mess. So I stopped and paused to do what I was doing to come and do this, because I committed myself to doing this for you guys tonight. So enjoy it. Hopefully all the information I gave you guys helped you to help you understand how you can manipulate your entire system off of one piece of equipment, because everything tonight that I ran was powered off of this one service plug right here, 240 volts. So, and this cord's quite long actually. I think I made it way longer than I needed to, more like about 7 foot long. And with that said, I have it tied in with probably another, 10-12 feet of extension cord here. So I'm not going right into the wall, I'm going through cord too. So there could have been a little loss there. I wouldn't expect too much. These power supplies seem to run really efficient. So again, I'm very pleased with them. Hopefully you guys are as well. Hit me up if you're looking for something of this nature. PM me. Grab my phone number, shoot me a 21. Catch you all later. Thanks a lot for watching. Aloha, Rudy out there and all my 808 brothers in the middle of the Pacific Ocean, hanging out, having a good time. I'm out of here. Take care. God bless.